Greetings, class. Dr. Williams here. We're going to calculate 4 things in this video. Population variance, population standard deviation, sample variance, sample standard deviation, and we're going to show how Excel has a shortcut to calculate these things. And finally, we're going to see if Microsoft Copilot, our AI, can do this right itself or not. So, notice I have 2 sheets in my Microsoft Excel file. Do you see them? This is population variance. This is our friendly home run slugger, Hank Aaron, and his home runs. We've seen these before. Then I've created a new sheet over here. I've created a fake sample. Let me get that green rectangle out of there. I've pretended to gather what they call sample data. What is sample data? Well, you might want to know something about a population of people, but you don't have the time or money to ask them all. So you randomly select some of them and ask them. That's called a sample. It's very common in political science. If you want to know, try to predict like who's going to win the election, let's say the presidential election. Well, around 150 million people vote in a presidential election. You can't ask them all. That's the population of people that vote. So you try to pick some at random. Usually they pick around 1,000 at random. And they ask the 1,000 people how they're going to vote. And they use that sample information to infer something about the whole population. Now, they're never going to get it exactly right. That's why when you see a political poll, they should tell you the margin of error. We're going to get into this in greater detail as the semester goes. But, so I've created a fake sample here. I am a professor. I don't have time to do anything except create fake data. So I pretended I chose 20 people in a town of 10,000 and asked them how much they spent on groceries last week, and I put the numbers here. So this is like a fake sample. So there's a difference, it turns out, when you calculate the population variance and standard deviation versus the sample variance and standard deviation. It's a very small difference, but it will change the answer. So you don't want to confuse the two. Make sure you don't confuse population variance and population standard deviation with sample variance and sample standard deviation. These things are a measure of what's called dispersion. How spread out the data is from the middle. Look at these home runs. The middle is around here, right? The lowest one is 10. That's pretty far from the middle. The highest one is 47. That's the dispersion. You could calculate the range, right? The range is 37. We already did that in the prior video. But that gives you some information, but it doesn't tell you how squished the data are toward the middle. You know, a lot of things that occur in life, they're squished toward the middle. If you looked at Prairie View's grade point averages of all the students, most of them would be near the middle. There'd be some near the top. Those are the good students. They're studying hard and working hard, but not very many. And then some of them would be near the bottom. Those are the bad students who are about to flunk out. But there's not many down there either. Most of them would be squished to the middle. So these measures of dispersion, which statisticians have figured out, called variance and standard deviation, not only give you some idea of how spread out the data is, but also how squished it is toward the middle. Now, Hank Aaron's home runs, I don't know, they don't seem too squished toward the middle. Most of them are actually up toward the top, don't you think? The sample variance here, now I've ordered these from smallest to highest. I don't know if most of them are squished toward the middle or not. I think they are. But anyway, these measures of variance and standard deviation will give us that information. So first we're going to calculate it manually. By the way, there is a formula in the textbook for all of these. I'm not going to use the formulas. If you like math, you should probably look at the formulas. We're going to calculate them first by hand. And then I'm going to show you a function in Excel that will do it all for you. And then we're going to see if our friend Microsoft Copilot, which sometimes gets things right and sometimes gets things wrong, can do it itself when we feed it the data. All right, so first we're going to calculate it manually. There's a bunch of steps. We need to first count the data. How many are there? In the formula, that's called N. Actually, I think our book uses a capital N. It doesn't matter whether it's a small n or a capital N. So we know from, since we used this data before, there's 23. You could just type it in. But if you want, you can also use that Excel formula count, right? That counts how many there are. $23, yeah, we know that. So we need that information. We're going to save it for later. We also need to know where the middle is. That's the mean. Calculate the mean. And we could manually calculate the mean, which would mean we'd have to add all these up and divide by how many there are. Or we can just use, remember the Excel function that calculates the mean. It's not called mean. I don't know why. They should have called it mean. They called it average. And they have to stick with it, you know. It would be much better if they called it mean. Because there's different types of averages. In particular, median is also an average, isn't it? But anyway, to calculate mean, you got to use the average function in Excel. And then grab all of the data. Put a parentheses. And hit enter. Remember, we calculated this before. So he averaged about 32.8 home runs per season, which is just amazing, especially in that era. So we're going to use these later. Now we have to create a couple of columns. We have to figure out how far each one of these is from the mean. Some of them are below the mean. They're dispersed below the mean. These seasons when he had a low amount of home runs. And some of them are above the mean. So we have to calculate the distance. When something is below the mean, the distance is going to be a negative number. Let's say, we're going to do it in column B. Column B, calculate the distance each thing is from the mean. These are sometimes called residuals or something like that. We don't really have to call it anything. Distance. So we're going to create this column from mean. So like for this one, 10. How can we calculate how far that is away from 32? Well, we're going to subtract. So we do equals. We click on the 10. Minus. Click over where the mean is. F2. Now we're going to do this for each one of these. Now there's a shortcut that we can use, but we have to tell Excel that this F2 never moves. It always stays right here. It doesn't change like rows. Now how do you tell Excel that something never moves? You put a dollar sign. You see this F2? That's where this is, right? It's in row F, column 2. That's what F2 means. Row F, column 2. We want to tell Excel never to change the row. It's always in row 2. The way you do that in Excel is you put a dollar sign in front of the 2. Why do you put a dollar sign in front of the 2? I don't know who decided that, but they did. This is telling Excel the mean is not going to move. This is going to help us. I'm going to show you a much faster way to do the rest of these. So put that in and hit enter. We have negative 22.8. This was his worst home run season. He's 22.8 home runs below his mean. Now we need to do this for each one. Now we could manually do it. We could do this one just like the one we did above, right? This minus this. But then we'd have to keep doing that and do it 23 times. That's, or 22 more times. That's a pain in the neck. There's a shortcut in Excel. If you're creating a new column, first let me put the green rectangle here. If you're creating a new column and it's next to another column of data, you can copy this formula and it will automatically go all the way down to the end. Excel is good like that. Now to do this right, we have to have this $ in here. We're telling Excel, look, I want you to copy this formula down, 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 but never change where the mean is. The mean is not going down, down, down too. The mean is just sitting here. That's why we have this $, okay? So here's the shortcut. There's this rectangle here. You see how I have the green rectangle surrounding the minus 22? Well, at the bottom right, there's the magic little square. You see the magic little green square? And if I have this anywhere, it's a white cross. See how it's a white cross? But if I hover over this, it turns into a black cross, and black is powerful. Once you're here, you can double click. Let's double click and see what happens. Ready? It calculated all of the differences from the mean for all of them. If we click on an individual one, it copied the formula. You see? It copied the formula. It copied the formula. This is why we needed this $, because the mean just sits here. The mean doesn't go down. That's why the $, is so important, right? But now we see, like his best season, he was 14 home runs above his average. His worst season, he was 22 below. So his worst was much worse than his best. Anyway, we've calculated the distance from the mean. Now we're going to need a third column. This is the last column we need. You see how some of these are negative and some of these are positive? Well, that's not good, because if we added them up now, they would cancel each other out, kind of, right? So we want to get rid of the negatives. We're going to square each number in column C. In column C, square each number that you calculated in. There's no spell checker in Excel. I'm getting too used to it. So you gotta spell carefully. In column B, we want to make all of these positive, and the way it's done is by squaring them all. You know, when you square a number, it becomes positive if it was negative, right? Because negative times negative is positive. Now, what does square mean? It means multiply the number, raise it to the 2, right? Raise it to the power of 2. Square of column B numbers. Raise to the power of 2. I forgot my n here. Let's do the first one. Equals. Now you know how to raise a number in Excel? You got to use the hat on the keyboard that's on the same key as the number 6. This hat thing, that's what they call it, a hat. Does it look like a hat? We're going to square it, raise that. This means you raise it to the 2. That means negative 22.8222 times negative 22.8222. It's going to become positive because negative times negative is positive. You know that, right? Let's do it. 521.03025547. Now, we need to do that for the rest of them. But we can use that shortcut. Go up to the magic little green square, wait for the cross to turn black. Now double click. It does them all, right? Now they're all positive. You see how the ones close to the middle are very small? You see that? The ones farther away are much bigger. Now what do we have to do? We have to add these up. These are called the squared residuals, by the way, or something like that. At the bottom of column C, column C. Add up the numbers. I will put it in bold, okay? I will put it in bold. Add up the numbers. Now, you don't have to do it at the bottom of C, but we're gonna, okay? In fact, why don't I just put it over here? It might be confusing. You see, some people don't watch the video. They're too lazy. And they just look at the spreadsheet, and then they won't know what that bottom number is. I'm always thinking about the students who are lazy, you see? So let me just put it over. Let me just put it over here, okay? I'll put it over here. Add up the numbers in column C. I'll put it here, okay? But now here, let me move this over a little bit. Like that. So I'm gonna add these numbers up. I'm gonna put it here. Okay? So equals, remember, sum, grab them all. Close the parentheses. Now, my software wants to make it a percent. We don't need a percent. I think this is because I'm reusing this spreadsheet and I deleted some stuff, but I didn't change the formatting back. We need just a number, right? We don't need a percent. We can just use general. That's the number there, 2751. Let me make that bold. Okay, we're almost done, by the way. What do we have to do now? Divide the number. Hey, did you hear my phone going off? Sorry, I had to pause. I put the phone on silent now. Anyway, divide the number in 5. By the count. And okay, I gotta move everything over. This is looking, that looks better, right? Count the data. Calculate the mean. Create these two columns. Add up the stuff in column C. Divide the number in part 5 by the count. So in other words, we're gonna do it right here. This divided by this, right? This is the variance. Let me make it a special color. Maybe not red, huh? Green, purple, yes. This is the variance. In particular, it's the population variance. Okay, that's the population variance. So let me bold that. Now, one more step, and we'll get the population standard deviation. Take the square roots of the number in part 6. See, we squared them here. If we take the square root, we're canceling that out. So how do we do that? There's a function in Excel to take a square root. It's called SQRT. Oops. Click here. 10.937181. That's the population standard deviation. I'll make that purple and bold it too. That's the population standard deviation. Let me slide over a bit here, okay? The population standard deviation. Now this number is an amount of home runs. This number is in the same units as our original numbers. In this case, it's home runs. This number is not in any units. It's really in squared home runs, but what the heck does that mean? It doesn't mean anything. Nobody really understands that. Now, some statisticians like to talk about squared home runs or something like that, but a business person is like squared dollars. What is that, squared dollars? This one is in home runs. The standard deviation is expressed in the same units as the original data. That's a fact. In other words, I spelled original wrong. I desperately need a spell checker for Excel. In other words, well, in this problem, the standard deviation is, I'm just going to copy the number, 10.937181 home runs. That tells us how spread out the original numbers are. Now, that was quite a bit of work. Well, I don't know. It took us 20 minutes or so. The Excel has a shortcut. Let me go back over here. Excel has a shortcut. Excel function to calculate population variance is called var.p, variance.population. You see how that works? So let's see if we get the same number. If we don't, I have to start this video all the way over because I made some mistake. Well, that would really stink. So let's try it over here. Equals var, by the way, you don't have to capitalize, dot p, open the parentheses. Let's grab the original data way over here, right? Grab the original data. I hope we get the same answer. My life is hanging in the balance. Look at that, it's the same answer. Hooray. I'm a competent teacher. So you see, you can use that. I don't mind. Why would I mind? I wanted to show you how it's calculated, that it's a measure of dispersion, how spread out stuff is, rather than just have you calculate the number and not know what the heck it is. But now that we know how to do it, there's an Excel function to calculate the population standard deviation. Calculate population standard deviation, STDEV dot P. Let's try that. Equals STDEV dot P. Go grab the data. And I hope we get the 10.9371. We do. Now let's see if our AI will get this right. I'm a little skeptical because remember when we tried to do mean, median, and mode and all that, it got that wrong. Let's see. Let me grab this data. I'm incorporating AI into the course. See, that's what I'm doing. It's not working very well, but I am incorporating it because my College of Business asked me, ask us all. I hope it gets better. Maybe next year it'll work better. You know, they keep improving it. Here's Copilot. I got it open. I'm logged into my own account. For this data, calculate the population variance and population standard deviation. There's the data. We don't want the picture. That's the data, right? Am I missing one? Where'd the 10 go? Oh, it's over here. Maybe that's why I got it wrong before. Oh. See, there's the formula. I don't know, maybe because I didn't have the data in the row here. Oh, we got the 10 in there. It rounded the mean to 33. That's a mistake. Don't round the mean. We got 211.09 and 14.53. Well, that's wrong. That's wrong. It only has 22 again. It missed one of the... It got the 10. I don't know which one it missed. It has the 47. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There's 23, man. I don't know how it's missing one. See, it has the 10. I was worried it wouldn't get the first one, but it did. It has the 47. I don't even know. It missed one of them. It got 726, but we know he hit 755 home runs. It missed one of them in the middle. I don't know. And it rounded the mean, which is a mistake. So our experiment with AI so far is going terribly. It's not doing a very good job. And this is I guess, tells you that you should not use it when doing statistical analysis until they improve it. We'll keep trying. I did try it for something we're going to do later in chapter 8, confidence intervals. It actually worked for that. So when we get to chapter 8, I'll show you it works for that. Anyway, this video is now 28 minutes long. I was going to do the sample variance, but the video is too long. You're not going to keep watching. So I'm going to stop this video and then I'm going to start right up and we're going to do sample variance. And you're going to see it's very similar to this. Just one difference right here. Okay? But I'll end this video and then I'll start in the next video with the sample variance. All right? Till then, Professor Williams is saying, have a good day.